In this video, we will consider another example for converting NFA into DFA. In previous video, we have already discussed why we need to convert NFA into DFA. Let us consider the example where language contains all the set of strings in which the second symbol from the right hand side is small a. So string is defined over alphabet AB and the second last symbol should be A. So the basic DFA would be A and A comma B. So last symbol can be either A or B, but the second last must be A. And before this we can read any symbol. So this is the correct NFA for given language. Let us convert this NFA into DFA. So first we will derive the transition table. As we know, in all rows we have to put the states of the NFA, and in column we have to write down the alphabets of the NFA. And in intersecting cells we have to write down the appropriate transitions. And in front of initial state we have to put arrow mark, and in front of final states either we will put star or we can have a circle as well. Now we will start with the initial state and we will find out delta transition on both the inputs A and B. So on input alphabet A, transition leads to set of states A and B. So and on transition B it goes to state A. AB is a new state. We have to keep generating successor of newly generated states until all states are processed. So now in next step we will generate the successors of state AB. This is our partial DFA for step 1, where on reading A it is going to state AB and on reading B it remains onto the same state. Let us generate the successor of AB now. So delta AB comma A, so that is nothing but it's a union of delta A comma A and delta B comma A. When we look at into the transition table, we can easily find out that this is nothing but union of AB and C, that is ABC. So ABC is a new state which is not yet generated. So we need to generate successor of that as well. Let us now find the successor of state AB for input B. So that is AC, and as we can see AC is also not processed yet. So AC is a new state, and that also we need to process and generate the successor of that. So this is the partial DFA for step 2, where we are generating two states AC and ABC, and you can see that C is a final state in original NFA. So whichever states contains C in DFA, they will also be the final state. So ABC and AC both will be the final state, and hence there are double circle. Let us generate successor of AC. So on reading input A from state A and C, it gives A and B, and AB is already processed in step 2. So we don't have to consider it. I have already color coded. Whenever it's a red, it means it's a new state and we have to generate successors of that. And on reading input B from AC gives us A. A is already explored in step 1. So we don't need to process it. So only links will be updated because no new states are generated. So there will be just a links updation from state AC on input A and input B. So this is the partial DFA after step 3. Still we have one state left, that is ABC, and we have to generate successor of that. So when we generate the successor of ABC on input A, it remains same ABC. And on input B, its output is AC, and AC is already processed in the previous step. It means in step 4 also we are not getting any new states, so there will be only link updations. And after step 4, the DFA will look like this. Now all states are already processed, no new state is left, so this is our final DFA. As you can see that NFA had only 3 states, but DFA can have more states. And here it is 4, and this is the transition diagram for the generated DFA. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye bye.